Hey, pre-algebra. We're starting lesson 9.5 today, which you can follow along in your book with me on page 507. Come join me. Do some of these practice problems with me, and then we'll do some of the problems right out of your work today. We're going to talk about something called scientific notation today. Scientific notation is a special way to write really big numbers like these in a way that are easier to look at and understand quickly. So we're going to take really big numbers like that and write them instead like this. The reason it's called scientific notation is they use this type of writing numbers in science a lot, because in science you often deal with really, really big numbers like the distance in miles to some of the stars in our universe, or really, really tiny numbers like the size of a cell, right? It would be like 0.001 centimeters wide or something. And so in science they often deal with really big or really small numbers, and to make them easier to work with, they take big numbers and they shrink them down to looking more like this. So we're going to teach you today how to write numbers in scientific notation like that and work with some numbers that are in scientific notation. So here we go. So the first thing they're going to want you to do is to express, that's a fancy way of saying write, each number in standard form, okay? And so standard form means the way a normal number looks. So 10 to the third power, you know, would be 10 times 10 times 10, right? 10 times 10 is 100. 100 times 10 is 1,000, right? And so really we're taking 2 times 1,000. So in other words, we'd get 2,000, right? Now there's a faster trick to think through these powers of 10 that they're going to be working with in scientific notation. Here's how you can think it through. This power here tells you how far to move the decimal, either to the right, if it's a positive number, or to the left if it's a negative number. So notice we're going to move this decimal place 3 to the right. So it used to be right here, right? If you have a number without a decimal, picture it being right after it. We're going to go 1, 2, 3 places to the right. And notice how we get the number 2,000. Okay. Let's do the same thing with this one. 6.8 times 10 to the fifth. Remember, that would be like 10 times 10 times 10 times 10 times 10, right? Or in other words, the little shortcut is to think, I'm going to move my decimal 5 to the right. So here's where it used to be. Let's move it 5 to the right. 1, 2, 3, 4, 5. And then fill in your loops with zeros, and you've got it. So that's 680,000. Now remember, if it's negative, you're going to move your decimal to the left. So this one we should move to the left 4 spaces. So here's where it is right now. 1, 2, 3, 4. And then fill in those loops with zeros and put a decimal there. So this becomes 0.000325. Okay, so that's how you change numbers into standard form. One more of each. So notice negative power, so I should move it 3 to the left. Here's where it is right now. I'm going to go 1, 2, 3, and fill in those extra loops. And I end up with this as my final answer. Make sure to erase your old decimal so it's not confusing to me when I'm looking at your answers where your decimal should be. How about this one? Notice we're going to move it 7 to the right. So here's where it used to be. So we're going to go 1, 2, 3, 4, 5, 6, 7. Fill in all those extra loops and bring it right there. And then don't forget your commas. Remember, when you're doing commas, you always start from the right and move your way to the left. Every 3, you put a comma. 1, 2, 3, comma, 1, 2, 3, comma. So that would be 59,400,000. Okay, then they're going to have you put normal numbers, standard form numbers, into scientific notation. Here's how you do that. In scientific notation, you always end up with only 1 digit before the decimal every single time, okay? So we need to move the decimal so that it only has 1 digit before the decimal. And then we're going to keep track of how many times we're moving it, because that's going to become the power, okay? So, for instance, here's where this decimal is right now. We need to move it so our number only has 1 decimal place, or 1 number before the decimal, I should say. Here we go. 1, 2, 3, 4, 5, 6. So we're going to move it right here. Took us 6 spots to do it. So we're going to say times 10 to the 6th. Okay. So notice if I took this 4.0 times 10 to the 6th, I'd move it back 6 over, and I'd end up where I started at, 4 million, right? So let's do the same thing here. Let's move the decimal. It's right here right now, right? If you don't see a decimal, always picture it at the end. Let's write this one in scientific notation by moving the decimal place to where it's only got 1 number before it. So here we go. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one would become 3.27. You can skip all the other extra zeros times 10 to the 9th. Notice how that would get you back to the original number again. You've got this really tiny number, but you're taking it times something big. So if you would do that, you'd end up back at this big number again. One more. Take a look. Here's where the decimal is now. Let's see how many times we have to move it. 1, 2, 3, 4, right? So this would become 1.89 times 10 to the fourth. Let's go with little numbers now. Notice we're going to make these little numbers bigger when we move the decimal. So then our power should be negative so that it can eventually go back to its original small number again, right? So take a look. Let's move this decimal 1, 2, 3, 4, 5, 6. 5.3 times 10 to the... Now notice we made it bigger, right, than the original number. And so we would need to make it smaller again by taking it times 10 to the negative sixth. Okay, so if you're taking a tiny decimal and making it bigger, then you need to have a negative power to make it smaller again if you put it back together as the way it originally appeared. Okay, so let's do this one. Notice I need to move the decimal, so there's only one number before the decimal. So here I go. 1, 2, 3, 4, 5. I'm going to move it there, so it becomes 4.0 times 10 to the negative fifth power, because I made it bigger. If you make this number bigger, then you've got to have a negative power there. If you make this number smaller, then you've got to have a positive power there. So they kind of work in opposites like that. All right, so notice here again, we're making a big number smaller. 1, 2, 3, 4, 5, right? So this time, our power is going to be positive. Do you see how we made our number smaller? So to make it bigger again, we've got to have a positive power. If we make our number bigger, then we've got to have a negative power at the end to get back to that original small number. Okay, so hopefully that's making some sense. You can put numbers in order that have scientific notation, that are written in scientific notation, by following these simple steps. First, look at their exponents. Okay, if they have the same number of if they have the same number of decimal places, which they should if they're in scientific notation, then the bigger the exponent, the bigger the number, right? So if you're taking something times 10 to the fifth, that's going to be way bigger than something times 10 to the second, right? And then if they have the same exponent, if they're both 10 to the fifth, then you have to look at their factors. In other words, you have to look at the number before the times 10 to the fifth and see which one's bigger, okay? So which of these would be the smallest or the least? Notice this one has the smallest power, so that one needs to go first. Okay, so we can cross that one out. Notice these ones have the same power, so now we have to actually look at the decimal and decide which one's smaller. This one's actually smaller, so 3.82 times 10 to the fifth would be second, and then 3.94 times 10 to the fifth would be third. Okay, so that's how you put them in order. First, put them in order by their powers. Notice our smallest power went first. And then if they have the same powers like these, then you got to look at the actual decimals and put them in order by that. So one more quick one. Take a look at these. Notice this one is really tiny. I know in order to get it back to its original number, we'd move it 2 to the left. So this number is really like that, right? So that's going to be our least one for sure. Okay, now be careful about these next two. Okay, this one has no power at all. But careful, what would happen if we worked with this one? Let's make this one a standard number again. Notice times 10 to the second, so I'd move it 2 to the right. This is the same thing as 394. So that one actually goes second, because that's the same as 394, because I'd move the decimal 2 to the right, right? And this is 400, so that would have to go last. So sometimes you have to kind of think through, what would it look like if I wrote it as a normal or standard number? And then you'll see, ooh, that's a little bit smaller than this, even though that has a power. And this one doesn't. This one ends up being bigger anyways. Okay, so you kind of have to think it through that way sometimes. All right, let's do a few right out of your work. Feel free to put these first. I'll find them. Notice this first section, they want us to write it in standard form. So let's do a couple of those. Number 1, we're going to write in standard form by moving the decimal 3 places to the right, right? Because we're taking it times 10 to the third. Or in other words, we're taking it times 1,000. 10 times 10 times 10, right? So let's move it 3 to the right. Here's where it used to be. 1, 2, 3. Add an extra 0. Don't forget to come back and put your commas. Always start from the right and count 1, 1, 2, 3, comma, right? So this becomes 4,160. Let's write this one in standard form right here. 3.2. Now we should move the decimal 2 to the left this time because it's a negative number. 1, 2. And move your decimal there. And so this final answer becomes 0.032. Okay, now let's go the other way and take a standard number and write it in scientific notation. Remember our rule for writing in scientific notation? We should always have one number before the decimal place, okay? So here's where this decimal is right now. Let's move it until we've only got one number before the decimal place right here. Ready? 1, 2, 3, 4, 5, 6. So we're going to say 1.6 times 10 to the 6. Remember, we made the number smaller, right? It used to be huge. We made it smaller. So to make it bigger again, we'd need a positive power of 10 right here. Let's do the same thing with this one. Let's write number 6 in scientific notation. So here's where the decimal is right now. We need to make it go that way so that it ends up right there, right? Because we want one number before the decimal place always. So here we go. Let's move it. Ready? 1, 2, 3. So it becomes 8.0 times 10 to the... Now notice, we made it way bigger, didn't we? It used to be this little tiny decimal, so we'd need to make it smaller again. So times 10 to the negative 3 would be our correct answer for number 6. And let's do one of the ones where you have to put them in order. Number 8 would be one example of that. So let's put these in order. Let's think through what they would look like. This one, if I moved it to the right twice, would be 340, right? This one moving to the right twice would be 350. This one I'd move to the left twice, so it would be that. So it's a tiny one, and this one's just plain old 400. So which one comes first? Write them the way they originally appeared, right? This is our smallest one. So 3.7 times 10 to the negative 2 is really tiny. That comes first. That one's done. Next smallest is going to be this one. Don't forget to write it the way it originally appeared. 3.4 times 10 to the second. Okay. This one comes next. 3.5 times 10 to the second, right? And that leaves us with 400 as our biggest one. So there's one example of putting them in order. So that's an example of all the different types of problems you'll face. I think you guys will do really well today, but I'm here to answer questions if you run into some. Have a good day.